All right, this is Mr. Warwick. I'm going to walk you through these notes for Tuesday. This is 3-2-10, rectangles, rhombi, and squares. So first off, you're going to want to pause the video here. You're going to want to take down all of the properties of rectangles. They get their name from having right angles, so all four of the angles are right angles. All of the same properties of parallelograms that we had where the opposite sides were parallel and congruent, those are all here. The opposite sides are parallel congruent, the opposite angles are congruent, the consecutive angles are supplementary, the diagonals bisect each other, and not specific to rectangles, the diagonals are going to be congruent. Okay, so again, the parallelogram only made special by the right angles, so then we get the rectangles. The congruent diagonals are specific to rectangles. So to prove that a parallelogram is a rectangle, which we're going to spend some time on this, we're going to do this again. All you have to do is show that the diagonals are congruent or prove that it is a parallelogram and that it has four right angles. The next one is the rhombus. The plural is actually rhombi. It's kind of a weird thing, not rhombuses. So if you are dealing with a rhombus, which this inner shape here on the Brazilian flag is a rhombus, it's a parallelogram and all four of the sides are congruent. So again, you'll probably want to pause, write down these characteristics. All four of the sides are the same length. The opposite sides are parallel, they're congruent. The opposite angles are still congruent. The consecutive angles are still supplementary. The diagonals are going to be perpendicular bisectors of one another. Doesn't really happen in the rectangle or in the parallelogram, but in the rhombus, we have the diagonals being perpendicular bisectors as well as bisecting the angles that they are on. So again, if a parallelogram is a rhombus, the diagonals are going to be perpendicular. These are the things that are specific to the diagonals. And if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. So here's the perpendicular, here's bisecting those opposite angles. So if you are going to prove that a parallelogram is a rhombus, remember we still have all those same characteristics that a parallelogram has, but to prove that this is going to be a rhombus, you show that the diagonals are perpendicular, you show that the diagonals bisect the opposite angles, or you show that one pair of consecutive sides is congruent. Because again, if we have a parallelogram, we know the opposite sides are already congruent. So if you can just show that two consecutive ones are going to be congruent, that should be enough to make it a rhombus. The last thing we have is the nice big Venn diagram here. So everything in the box should be parallelograms. We have some that don't fit any of these other ones. If it's a rectangle, it's in here with its four right angles. If it's a rhombus, it's in here with its four congruent sides. And the overlap between rectangles and rhombus is square. To prove that a parallelogram is a square, all you have to do is prove that it's a rectangle and prove that it's a rhombus. So it doesn't seem like there's much to do here when it comes to the square, but it's actually more steps because you have to remember what's going to make something into a rhombus and then what's going to make something into a rectangle, and it has to do both. On this one, if JKLM is a rectangle, how long is KM? You would have to remember that these two are going to be congruent to one another because the diagonals bisect each other. And you figure out those diagonals, you figure out the value of Y, you put it in, and then KM is going to be congruent to the other one. If this is a rhombus and the measure of BCD is 102, find BAC. Again, we should find this bisecting and the same kind of thing over here. Your assignment is going to be on Schoology today. Let me just pull it up real quick so you can see what this is going to look like. I'll search here. A rectangle. Here we go. Rectangle, rhombus, square. Okay, and as we look at it, classify the parallelogram. So tell me Is this a rectangle? Is it a rhombus? Is it a square? What's going on with any one of these? And how can you tell? And then put parallelogram, rectangle, rhombus, square, name each one for which this is true over here. Go down through, determine whether these are true or false. Classify the special quadrilateral, find the values of x and y. Here's the diagonals of a rhombus, here's the diagonals of a rectangle, here's the diagonals of a square, and that's the end of the assignment. So it seems like there's quite a bit. It's really not that bad. We'll probably go over this when I come back. But yeah, that should be it for today's assignment. If you have questions, save those for when I come back. I should be there for the rest of the week. The tennis tournament was moved from Thursday to Tuesday, so that's why you're getting this video. All right, we'll see you.